Hi folks, welcome back to 10.2 Ellipses and Circles. So right now we're going to take a look at two more graphing examples and we're going to use our completing the square to help us with these questions. So let's take a look at number 6 here. I'm going to rewrite this equation below and we're going to use this to help us find the general form of the ellipse equation. Okay, so the first thing I'm going to do is I'm going to sort of group my terms. I'm going to take the 4x squared minus 40x and I'm going to write them together in the front. Then I'm going to group my y's. So the 9y squared plus 36y will come next. And then I'm going to take my 100 and I'm going to subtract it to the other side. So in cases like this, we're actually going to be completing the square not just one time, but 2 times in the same problem. So let's start with the x's. I'm going to go ahead and factor out a 4. So factor out. So 4 x squared minus 10x plus, I'm going to factor out a 9. 9y squared plus 4y. And that's going to equal negative 100. Now I'm going to complete the square for the x's and I'm going to complete the squares for the y's. Now one thing I want to be careful about is whatever I subtract for the x's, I'm going to need to multiply by 4. And whatever I subtract for the y's, I'm going to need to multiply by 9. So that's not something we've seen before, but we just want to make sure that whatever we're adding and subtracting is staying the same. So here I have my 4. When I complete this square, it will be x, let's see, half of 10 is 5 squared. And then I'm going to take away 5 squared plus 9 times y plus half of 4 is 2 squared minus 2 squared equals negative 100. All right, so let's take a look. We've got 4 x minus 5 squared, so I'm distributing this back in, and then minus not 25 but minus 100 because I have to distribute the 4 back in, plus 9 times y plus 2 squared because I'm distributing the 9, and then minus not 4 but 36. Okay, now I'm going to take this negative 100 and the negative 136. I'm going to add them to the other side. And so that's going to give me 36. All right, almost there. We're going to divide everything by 36 because I want to make the right-hand side equal to 1. So x minus 5 squared over 9 plus y plus 2 squared over 4 equals 1. All right, I'm going to take one more step when I write this up above, and that is to change this into 3 squared and this into 2 squared. So the equation we'll be working with is x minus 5 squared over 3 squared plus y plus 2 squared over 2 squared equals 1. Okay, now based on the 1, the something squared, and the plus sign, I know that I have an ellipse. And so my question is, will it be an Ernie or will it be a Bert? Oh, that's not a Bert. Okay. So let's see if we can tell. Well, the number under x is 3 squared, and the number under y is 2 squared. So I'm guessing that this is going to be of this shape because the number under x is bigger, so I'm going to go out sideways more. But let's start with our center. So our center here is going to be not -5, but +5, and not +2, but -2. And I'm going to go ahead and graph that center. So 5, -2 will bring me right here. Now from the center, I'm going to go out to the side 3 units, so to 8 and then to 2. Now I could figure that out by saying 5 plus or minus 3, -2, which would give me 2, -2, and 8, -2. Now to find the co-vertices, I'm just going to count what's underneath the y, which is 2 up and 2 down. And so that's going to give me 5, -2 plus or minus 2. That gives me 5, 0, and 5, -4 as my co-vertices. Now at this point, I could connect the whole ellipse, and I would get a shape kind of like this, all right? But we're not done until we find our foci. And so for an ellipse, we want to use c squared equals a squared minus b squared, because a is bigger than c. And when we plug that in, we will get 9 minus 4, or c equals the square root of 5. That means that the foci are going to be 5 plus or minus square root of 5, -2. And if we turn that into decimals, we will get we'll get 2.76, -2, and 7.23, -2. And those I can graph here and 2.76 here. All right, let's do one more example where we need to complete the square twice and see how that goes. So we're going to skip to question number 8. All right, now I can tell already by this setup that I'm going to have to do double completing the square. So let's do this. Let's take this equation down here. I'm going to group my x's, group my y's, move that 541. All right, now I'm going to factor and factor. All right, now I'm going to complete the square. And I'm going to complete the square again. Now I'm going to distribute back in. And I'm going to distribute back in. Okay, now I'm going to move the 625 and the 16. And that will give me 100 on the other side. Now, what am I going to divide by? I need to divide by whatever's going to make the right-hand side equal to 1. And you should notice with most of these problems that the fractions actually reduce really nicely. Almost like, I don't know, someone planned it that way. Okay? So if you're getting some weird numbers, it's not to say that it's never weird, but it is a good indicator that you should probably double check your work. Okay, let's bring this equation back up to the top, and we're going to make this 4 into a 2 squared and this 25 into a 5 squared. All right, I know this is an ellipse, and my question is Ernie or Bert. I know my center is going to be, change the sign for both of them, 5, 2. So I can go ahead and plot that point, 5, 2. And from here, I'm going to go ahead and plot my co-vertices. I'm going to go out 2 on either side. And I know that because I'm going to take the x value and I'm going to add or subtract 2 to get the sideways direction. That will give me 3, 2 and 7, 2, which matches my graph. I'm going to go ahead and plot my vertices. So from here, I'm going to go up 5, and from here, I'm going to go down 5. And I can represent that as 5, 2 plus or minus 5. And that will make 5, negative 3 and 5, 7. All right, looks like we're ready to sketch our ellipse, and it looks like it's going to be more of a Bert situation, a nice tall ellipse, not a wide one. And our last step here is to find our foci using c squared equals a squared minus b squared, because a is bigger than c. Okay? And we're going to get c squared equals 25 minus 4, or c equals the square root of 21. That means that our foci are going to be at 5, 2 plus or minus 21. So from our center, we're going up and down root 21. That will give us 5, negative 2.58. So that'll be about here. And that will give us 5, 6.58. And that will get me right up there. Okay? And so that's it for this third video. Come on back for the fourth video where we're going to take a look at writing equations just like we did at the end of parabolas. See you there.